For our next math lesson, we're on to linear and exponential growth. This is the 7th topic within the problem solving and data analysis category. On this question, it says some values of the function f are shown in the table. Which of the following functions could be f? So something to keep in mind here is recall from our Triple T math document, Tom's testing tips, our first tip says don't look at the answer options right away. They'll only confuse you. However, it can be useful to look at the answer format. And on this question, that's definitely the case. So we can see that we're trying to come up with the equation for this function. And whenever you have a table like this, and then you're trying to get the function, we're essentially looking for the regression model. And the easiest approach is using Desmos. So let's go to the upper right corner, just as we would in our own software, where we'll get the Desmos graphing calculator. We'll pull it up and we'll press this plus icon and choose table. And then for x1, we're going to go ahead and input all these n values, 0, enter, 1, enter, and then notice it starts to notice the pattern. So I can just press enter, enter, and then I'm good at 4. Now I'm going to go ahead and click into the y1s, and I'm going to input all these y coordinates, which they call f of n in the table. And so I'm just going to put 1, and then I'm going to do the / on my keyboard, and it makes a fraction bar for me. I'll put 2, enter, and I'll do the same thing here, 3/4, enter. Now you could choose to use College Board's keyboard, which is in the lower right corner of the software, and use those keys accordingly. But for me, it just feels a little bit easier to type them in. But just to show you, we could do 9 divided by, which makes the fraction bar, 8, and then continue from there. So I'll go back to my keyboard, type these in, and now we have these 5 ordered pairs plotted for us. And notice that over here, it says add regression. So we're going to go ahead and click there, and they give us a variety of options. The default is linear regression, but notice that's not fitting this model so well. And you could see that options C and D are both in slope-intercept form, meaning that those are following the linear model. Let's contrast that with the exponential model, which is y equals a times b to the x, where a is the y-intercept and b is the common ratio. And notice that options A and B are following that specific format. So we're trying to determine if it's exponential, like options A and B, or linear, like options C and D. So getting back to our graph here, we can see that the linear model, it's okay, but let's go ahead and test out one of the other models. Now you can see there's a ton of options here. We narrowed it down to either linear or exponential. So let's go to exponential. Oh, now that looks perfect. So we can tell it's definitely an exponential model, which means we could totally eliminate options C and D. And now we know it's either A or B, which means we're progressing nicely on our Triple T math document, where we already used the answer format from step 1. In step 2, we did something, which was utilizing Desmos to our advantage. Step 3, once you're certain on one part of the answer, in our case, that it's exponential instead of linear, we're able to eliminate the answer options that it definitely can't be. And now we're on to step 4, where we're going to analyze what makes, in our case, the remaining 2 options different from each other and choose the correct one. So the equation we get here is y equals 0.5 times 1.5 to the x. And something that's pretty neat is if you click right here, it'll go ahead and put that equation for you, and you can see it in red. If I click here, it removes the red and just shows the initial one, but we can keep it on there. And I know that you know what those decimal equivalents are in their fraction form. For example, 0.5 we know is 1/2, which doesn't really help us out because A and B both have 1/2 in the A value, and 1.5 clearly isn't 3, so we can tell it's going to be A. However, what is nice about Desmos is you could go right here, type in 1.5, click this icon here, and it'll turn it into, in this case, an improper fraction. Obviously, you could do the same thing with 0.5, but that's a bit of a waste of time. Now, we could also go to our graphing calculator, just type in 1.5 alpha y equals, and choose option 4, which is going to change it from either a decimal to a fraction or a fraction to a decimal. In this case, it changes it from the decimal to an improper fraction of 3/2. So regardless, we get the correct answer is A. So by far, Desmos was the easiest approach, and that's what I would do time and time again on the SAT. However, I think it's important for me to educate you on the best approach if you had to do it by hand in your own math class and you weren't given access to Desmos. So if I were trying to figure out, okay, is it exponential or linear, I would observe the fact that all the x coordinates are increasing by 1, which really enables me to just look at the y coordinates. So if I want to figure out if it's linear, that would mean that you're consistently either increasing or decreasing by the same amount. And so to test this out, you would take any y value and subtract the 1 immediately immediately to the left and see if that's consistent across the board. As an example, I'll go ahead and type in 3/4, and you could either choose, depending on your calculator, alpha and the variable key, which activates the horizontal fraction bar, or you could do alpha y equals and choose option 1. I'm going to type in 3 right, 4 right, minus, and then I'm going to go ahead and type in 1/2. So 1 right 2. So I'll press enter and I get 1/4. So if this were linear, then when I do the difference between any other y value and the one immediately to its left, let's say 9/8 minus 3/4. So 9/8 minus, I'll go here this time, 3/4. I should get the same thing, which I don't. So I know it's not linear. Again, we could eliminate C and D. And if it's exponential, then what should happen is you're consistently multiplying by the same thing, going from left to right. Well, if we want to figure out what that value would be, that multiplicative value, you do the inverse operation, which means instead of, like we did last time, subtracting the one immediately to the left of the y coordinate, now we're going to divide. So I'm just going to go back to this 3/4 minus 1/2 by clicking up a few times, pressing enter, and I'm going to go over to the minus sign and change it to a division key. I'll press enter. Notice I get 3/2. That should sound familiar, right? Let's do the same thing with 9/8 and 3/4. We're going to change that to division. And the fact that we get the same thing over and over tells us that that is the B value. That's our common ratio. And then the y-intercept occurs always when x is 0. So you go to where x, or they call it n, is 0, and the y-coordinate's 1/2, matching again perfectly with A. And remember, you got this.